This is the video for the Auto-Irrigation System by Oscar Flores, Francisco del Val, James Diaz, Zachariah Villanueva, and Mario Gonzalez.
Our primary objective was to automate the care of the succulent plant by monitoring soil moisture levels and providing water as needed. This ensures the plant receives the right amount of water to thrive while preventing overwatering. We also wanted to improve water efficiency by preventing wastage through precise monitoring of soil moisture. This helps conserve water resources and reduce water bills. We also wanted to consider the environmental impact of the system, such as reducing water waste and contributing to plant health.
The top-level requirement of this project is to design and implement an automated succulent plant care system specifically tailored for the Pacuvaria glauca blue quartz. This system aims to maintain optimal soil moisture levels by employing sensors, pumps, and controllers. Utilizing Arduino-based controllers, soil moisture sensors, water pumps, and MATLAB App Designer, the system was developed to automate the plant care process. It administers 45 milliliters of water for 4.2 seconds, precisely when soil moisture levels reach 90 to 100% dryness, effectively ensuring that the plant receives adequate hydration without the risk of overwatering.
This was the work distribution for the team. These are the component selection criteria. The Arduino is the brain of our system. The moisture sensors will measure the moisture level in each soil of each plant. The relays will control the water pumps. The water pumps will deliver the water to the plants, and the tubing will connect the water pumps to the plant pots. This was the schematic of our system. We have our Arduino, our moisture sensors, our relays, our water pumps, the plants, and the battery. For the flow diagram, we first have to power the Arduino, which would then power the moisture sensors. If the moisture sensors have a level greater than 540, the pumps will run and the water will flow until the delay is over. If it doesn't, the pump will be off and the water won't flow. We then have another loop which has the moisture data, and then the moisture data is going to be sent to the MATLAB App Designer, and then it will loop back to the Arduino.
During the prototype phase of the project, the primary focus was on fabricating a custom planter box specifically sized at 3 by 3 inches and 4 inches tall, as standard options were not available for purchase. After planting the succulents, the challenge shifted to configuring a system, allowing submersible motors to be immersed in a water reservoir, while additionally establishing a mechanism for tubes to extend from the reservoir to the planter box. To address this, the reservoir was strategically placed underneath the planter box, minimizing the distance the water needed to travel for controlled delivery to the plants.
Our final design was a laser-cut top box that contained soil and the sensors, a bottom box that contained the motors and water container. Holes were drilled into the lower box for motor wires to connect to the relay. The tubes from the pumps were placed into the plant containers, and holes were made to funnel the water into the pumps. We also had one capacitive moisture sensor for each plant container, and a power supply module was used to power the motors through the relay.
So I'm just going to show the quick setup of how we have everything. So we have our 4 capacitive sensors in each plant section. And on the sides we have tubing that go for each plant according to their pump. And on the sides we made holes in this box, which is our water container, for the tubes to go through. And in here we have our pumps, which can be seen right there. That's a focus. And our pumps have the tubing coming out, and each pump is according to one plant. And they're all held inside a makeshift holder. And that is basically our setup. So this is our system display on MATLAB App Designer. And this is just showing the values of plants 1, 2, and 4 after they went off. And the values are updated every 5 seconds, depending if no pump calls are used. And that is our system. So right here we have our final product. So we have 4 plants, all numbered 1, 2, 3, and 4. They each have their own capacitive moisture sensor, as well as a tube coming from their own respective pumps, which are located below here. And the pumps are connected to this four connection relay, and the sensors are connected to the Arduino, and then the 4 connector relay is also connected to our power supply module. And we use MATLAB App Designer for this, just right here, which shows the moisture percentages. And for our threshold, we found that it was between 540 and 550 for the analog input, read by our capacitive sensors. So our pumps will turn on when the moisture percentage is below 4%. And as you can see, plant 4 is our lowest percentage from the 4 plants, which is why on our relay, our 4th connection is turning on, meaning that our motor will turn on for plant 4, which is back plant back here. And right now there's no power being supplied because this button's not pressed yet. So after this next put, turn on the button, which the water is going to turn on from our motor. And you can see that the moisture percentage is going to be updated. It's at 91%. And our first so you could see, just for presentation purposes on Friday, I turned it off, but you could see that our plant 1 and our plant 4 went off, as well as our plant 2 a little bit before I turned it off. And essentially that's how our system works. Just want to leave one plant unwatered for presentation purposes. That's basically how our system works. So we found that our plant needs around 45 mLs of water, and our pump turns on, and our system's functional. And we found that around a time of 5.4 seconds of this height will give us the needed amount of water for each plant. And that is basically how our system works.
In conclusion, we successfully implemented MATLAB App Designer to create a sleek viewing experience of the soil moisture content of each plant in a functioning automated plant care system. Although the system works as intended, we would have liked to have added IoT for access to the moisture levels of the plants from the app. Since different plants require different amounts of water, we would have also liked to have added multiple presets for different plants. Also, some plants don't require as much maintenance and don't need to be watered as much, so adding a time schedule to the pumps can also be a future improvement to the system. We would like to thank Dr. Khan for his teachings and guidance throughout the semester. Here are our references, and this concludes our video. Thank you.